Right, we are proceeding with our lesson. Thank you very much indeed for taking the time as well as the trouble to be part of this lesson this particular afternoon. And without any doubt, I just want to indicate to you, as always, the lessons are brought to you by the STEM Digital School, presented by Africa Teen Geeks. And my name is Hendrik Makaneta. Feel free at any time to ask any question if you can. And of course, the lesson for today will be based purely on the 3D objects. And we are going to, at some point, calculate the surface areas of prisms. We will do so without doubt, taking into cognizance the wide range of faces that we have up to so far defined. Now, Musa, thank you very much, Lizanne, and Tlantla as well. I've noted your greetings in the group chat. So the calculation of prisms will be done in a fair manner, which will also take us back to how we have successfully defined the 3D objects. We want to carry on just to reinforce the understanding that a prism is a 3D object that has two parallel and identical faces that are polygons. And basically when we say that the faces are identical and parallel, we simply mean that they are congruent, meaning that they have the same shape and the same size. So basically that's what we mean. And of course, we take the definition to mean that basically prisms have a pair of parallel congruent faces. So those are the two things that I wanted to talk about, the parallel as well as congruent. But equally, a cuboid is just another name for a rectangular prism. So by now, we have spoken at length about a rectangular prism. And of course, a cuboid is just another name for the rectangular prism. So that is something that you need to remember. So when we talk about a cuboid and a rectangular prism, we are talking about one and the same thing. So it's just one a 3D object. But equally, a cube can be classified as another type of a cuboid, except that in a cube, all the edges are equal, meaning that all the sides of a cube are equal. So a cube is made up of a wide range of squares with equal length. So about 6 of those, if I can be specific. So there are 6 squares which are needed to complete a cuboid called a cube. It's just another type of a cuboid. So it's another type of a rectangular prism, also known as a cube. And lastly, we have defined a triangular prism as well. And I know that we have spoken at length about a wide range of polyhedrons, the pentagon or pentagonal prism, the hexagonal prism, and so on. But the last definition that I want to post at this afternoon is the triangular prism, which is a prism in which two parallel faces are triangles. So please make time to analyze these definitions so that you must be able to clearly find a surface area if you are called upon to do so. we have an example here of a triangular prism. And you've seen this triangular prism. You can see clearly that we have given you the different measurements. Those are some of the measurements that are given in this space. 4 centimeters, that is the breadth of our base of the triangle there, which is the rectangle. And of course, the 15 centimeters, which is the length, and the height of the prism, which is now 3 centimeters. And you can also see the other sides, 5 centimeters each. Those are the 2 sides that complete your triangle. And basically, I want us to focus on this particular prism. I want us to study this prism so that we can be able to answer some of the questions that will follow as a result of studying this prism. Once more, we know there are 2 triangles that are used to complete a prism of this nature, also known as the triangular prism. Remember that in just the definition here, I've said to you that a triangular prism is a prism in which 2 parallel faces are triangles. So the 2 triangles that you see in that particular prism, they are parallel. So you will recall the parallel lines in geometry. And we said that the 2 parallel lines cannot meet. That's how we define parallel lines. And even in this case, the parallel faces cannot meet. So we feel this morning that we must explain the 2 parallel faces being the triangles in this case. And after studying this particular prism, we need to be able to answer the following questions. The first one, is this a regular prism? Explain why or why not. And I will come to the regular prism. When we talk about a regular prism, we are referring to a prism which has a pair of parallel congruent faces. That particular prism is known as a regular prism. And when we talk about an irregular prism, we are talking about prisms that do not have regular polygons as their basis. In other words, their bases are not congruent, and they are also not regular polygons. In our case, in this case, we have got a rectangular, not a rectangular, but a triangular prism. And you can see that this is a regular prism because the 2 faces, or the 2 triangles rather, are identical, and not just identical, but they are also equal lengths. They have equal length, and of course, they also have the same shape. So to answer this question of whether the triangular prism is a regular prism or not, the answer is yes, it is a regular prism. Can we name the basis of this prism? The 2 bases. Remember, the 2 faces that are joined together by rectangles in order to complete the triangular prism. What are the names of those 2 faces? What are the names of those 2 faces? Let's go to the group chat. I see Natalie together with Onke, or Onke in fact, sorry, Onke Lesedi, together with Musa. You are quite active in the group chat. Now, can you tell us what are the names, or what is the name of the bases of the prisms that are found there in the triangular prism? What are the names? Lizanne McEwan says the bases are the rectangles. But remember, Lizanne, what I'm trying to check here, the two bases must be joined together by the rectangles. That is what we are trying to say. They must be joined together by a rectangle, or in fact, more than one. There are about 3 rectangles that are joining these two faces in order to complete the prism. For us to say this is a prism, it must be joined by these rectangles. For us to conclude that this is a triangular prism, then the faces that are going to be there, the basis of the faces will be the faces there will be our bases, which must be joined together. But it can't be a rectangle. I see Lizanne McEwan together with Natalie says they are rectangles, but they are not. They're actually triangles. You are joining 2 triangles together in order to complete a triangular prism. So basically that is what we mean. To say you join the 2 triangles together in order to complete a triangular prism. And that is what we mean. And I'm going to make sure that I define it clearly. And of course, we must also calculate, just to check how many faces are there in as far as this particular prism is concerned. So I hope that I've clarified you in relation to the basis of the prism. I know that if you look at this, let me not confuse you. If you look at this particular prism, the manner in which it is situated, one can assume that the base is a rectangle. Yes, of course. If you look at the manner in which this triangular prism is, the position of this prism, yes, you can see the base of the prism, that the base should be the rectangle, but the 2 bases that are joined together to form a rectangular, in fact, not a rectangular, but a triangular prism in this case, is the 2 triangles. Those are the bases that we're talking about. Those are the 2 parallel bases. So the first triangle is parallel to the other. That is what we know, that the first triangle is parallel to the second. And of course, those are the 2 faces that we're talking about. Now, the critical question that I want to ask is that how many faces does this prism have? How many faces are there in this prism? And I see that Lizanne McEwan is back to say there are 5 faces, and your answer is also corroborated by Lesedi, who also agrees that the 5 faces are there in the particular prism. And I fully agree with you, both of you. You are correct. There are 5 faces in this prism. There are 5 faces. The first 2 are triangles, followed by the rectangles. And of course, the rectangles are, the number of rectangles, there are 3. There are 3 rectangles. There are 3 rectangles and 2 triangles, which complete the number of faces in our prism. Now, at this point, I want us to calculate the surface area. But before we can calculate the surface area of the entire prism, I want us to focus on the bases, meaning that the 2 triangles. Let's focus on the 2 triangles, where we will be able to calculate, or in fact, yes, calculate the area. Remember that we've got 2 triangles, And I've given you the formula to calculate the triangle. You should know it by now. But for the purpose of this particular activity, I will just remind you, we said that the area of a triangle is given by half of the base multiplied by the height. So basically that is what I've put in the group chat. That is the area. That is the formula that you can use. That is the area that we can use to calculate the, that is the formula that we can use to calculate the area there. The formula. You can use the formula to calculate the area there. Right, calculate the surface area of the bases. Those are the surface areas of the bases. And I've given you the area there, the area to calculate. I see that Lizanne make E1. The formula actually is there given by the area, which is equal to half of the base, and then you multiply the base with the perpendicular height. So basically that is what we need. Half the base times the perpendicular height. So basically that is what we need. Half of the base multiplied by the perpendicular height. That is the formula that we need in order to squarely calculate the area. Right, I'm not going to waste any time. I will just show you how to proceed. Remember that when you look at your prism, you can tell here that your triangle consists of the base, which is 4 centimeters, and the height, which is 3 centimeters. I'm sure you can be able to use those to calculate the area. I see Lynn has already calculated the surface area of the entire. Yes, you have calculated the surface area of the entire prism, and you found 222 centimeters. That is correct, Lim. I agree with you. But for now, I wanted to show everyone that in order to calculate the surface area, all that you need to do is to calculate the area of every face. Now, Lynn, may I ask you, what did you use? Did you use the formula to calculate the surface area of the entire prism? Just tell me, what did you use? Or did you rather, did you calculate the area of every face? Because I don't want people to memorize the formula. I want people to be able to know that you can actually calculate the area of every face, and then you add all of those areas to find the total surface area, or what is known as the surface area. Lynn, did you use any formula? All right, I don't seem to see or hear an answer there from Lynn. But it should be clear at this point that Lynn has calculated the area. I hope that you did not just use your phone, because I know that if you have your cell phone and you are given the different sides, you can just simply put in, there's a program that you can use just where you just insert every value, the length, the breadth, the height, and so on. And then it calculates your surface area automatically. I hope you didn't do that, because the main purpose of this lesson is to make sure that you can calculate the surface area on your own without relying on any gadget or program, just to use your knowledge that firstly, you must calculate the area of the two triangles followed by the areas of the rectangles. Remember, there are 3 rectangles and 2 triangles. All right. So I'm just going to start. I'm going to start with the rectangles, and I do hope that you will be able to follow. Now, and we must get the same answer that Lynn got in this case. So the area is half a base, like I said, it's half of the base, and the base is 4, and then it's multiplied with 3, which is the height. So basically that is what you have there. So basically you'll have half of 4, which is 2, and then 2 times 3 is 12. So basically the area will be 12 square centimeters. That's the area of one triangle. And then if you multiply by 2, yes, it is multiplied by 2. Remember, half of 4 is 2, 2 times 3 is 6. So the area actually is 6. The area of one triangle, that is equal to 6. I see Onka, I saw your hand was up. So the area of one triangle is 6, and then 6 multiplied by 2 gives us 12. Yes. So for 2 triangles, the area there will be 12 square centimeters. And then we have got the 2 rectangles, where you must now use the area which is length multiplied by breadth. Remember that the 2 areas there, one of the lengths there is 15. So it's 15 multiplied by 5, right? It's 15 times 5. And then the other one, of course, area there will be 15 times 4. Okay. But the last one again, which is opposite the 15 times 5, then also that will be 15 multiplied by 5. So basically you have got 3 areas of the 3 rectangles. So the first one is you multiply 15 by 5. And then the second one, you also multiply 15 by 5. And as we know, 15 times 5 is 75. So basically, if you add all of them, you'll have to add 75 plus the other one, which is now 15 times 4 is 60. And then plus 75. So you'll have to have the sum there, which is 210. And remember that 210, we need to add the original area there of the 2 triangles. So 210 is the combined areas of your rectangles, the 3 rectangles, and then you add that to 12, which is the 2 areas of the triangles. And the answer will be 222 square centimeters there. So basically, 222 square centimeters, that will be the surface area of the triangular prism here. That will be the surface area of this triangular prism. 222 square centimeters. So basically that is what we will have. And by the way, the surface area of any solid is defined as the total area of all its surfaces. So all the faces, if you take the total area of those, then we talk about the surface area. So when you calculate the surface area of any solid, You need to be able to visualize all its surfaces and its dimensions. And that applies to prisms. You may not be able to see one side, but you must be able to visualize at times. You don't have to memorize the formula. You really don't have to memorize any formula in that case. So I hope that it makes sense. Let us now calculate the surface of the area. So we have now calculated the surface area of the entire prism. Now, remember that we defined our cube as well as our cuboid in the beginning. And of course, any solid can be classified as a geometrical 3D object. And when we speak of a polyhedron, we're talking about a solid which is bounded by parts of intersecting planes. And I've already spoken about the cuboid. When we started, I said that a cuboid is a rectangular solid with 6 rectangular flat faces. And a cube is just another rectangular solid with only 6 square flat faces. So any cuboid, just like any brick, which is shown in this case, it has 6 rectangular flat faces, it has 8 vertices and 12 edges. And this we know from yesterday when we started with this lesson. So you can see even in this one how the edges are defined or demonstrated. The vertex, like I said, where all the parts meet in that corner. And of course, you also have the length, the breadth, as well as the height. And a cube as well, it's a rectangular solid with 6 square faces. And all the edges in the cube are equal in length. So just remember that all the edges must be equal in length. Now, I've just told you now that the surface area is the total area of the flat faces. And by the way, you can use a net. You can use a net, which is a 2D shape, which can be folded together to form a 3D object. So a net is just a plane or a 2D shape that can be cut out and folded to form a 3D object. So I'm sure in grade 7, you were also introduced to the nets. If not, yes, in grade 7, you were introduced to the nets, and then you can actually fold them together to complete a 3D object. So you can use your own nets in a piece of paper just to complete a 3D object. But remember that when it comes to this topic, what is very important is also to know your measurements. Make sure that if you are working with different units, for instance, the first thing that you need to do is to convert your units so that at the end of the day, you have got the same unit of measurement. So conversion there, you can do it, you can convert meters to centimeters or centimeters to meters. That you should know by now. And we also have the formula to calculate the surface area of any solid. In this case, we are looking at the cuboid. We are looking at the cube. We're also looking at the triangular prism together with a cylinder. Now, in this case, you can see that we have got the formula to calculate the surface area of any of this. So if you have got all of those points, you should be able to find the surface area without any problem. Now look at the surface area of the cuboid. We've got 2 outside, and then you multiply that with the length times the breadth, plus the length multiplied by the height, and the breadth multiplied by the height. Why are we doing this? That's simply because if you take any cuboid, you can see that it has got 3 different faces. I'm talking here about a normal rectangular prism. A rectangular prism will have 3 different faces. In other words, it will have 3 different rectangles. One where you multiply the breadth with the height, one where you multiply the length and the height, and one where you multiply the length and the breadth. All right. So those are the 3 different rectangles. So you do the areas of those. And why do you multiply them by 2? That's simply because each and every rectangle has got the opposite angle, a rectangle of its own, and which must be equal. So basically, that is what we do. And then in a cube, you can see that the cube is quite different in a sense that in a cube, you simply take 6 and then you multiply that by the area of any face. If the length of if the length is given in a specific cube, then you know that the area of any face there will be length multiplied by length, which is length squared. And then if you multiply that by 6, this resembles 6 faces. You simply take one area and you multiply it by 6. Why? Because all the faces are equal in a cube. So in a cube, all the faces, all the 6 faces are not only identical, but they are also equal. So meaning that it's the same size and the same shape. And of course, the triangular prism is there, which we have also looked at. And then we also have a cylinder. Can you see that the surface area of a cylinder is given by the formula S is equal to 2 pi r, open bracket, r plus h, where h stands for the height, and r is the base of your cylinder. So h is the height of the cylinder, and r is the base. All right, great. Now I've got about 3 different prisms. The first one is a triangular prism, which is followed by a cube. And the last one is a cuboid, also known as the rectangular prism. Can we now calculate the surface area of the triangular prism? Can we now calculate the surface area of the rectangular, in fact, the triangular prism? Right. Remember, you don't always have to use the formula. You can actually calculate this by using every face. Remember that in a triangle, we are given the face, and then of course, you can be able to do that. For instance, the length there is, or the height rather, the height is 3,2, and then you also have 1 meter there. That's the height of your triangle. and the base is 1,7. So you can see that you can do half a base times the height, and then thereafter you can calculate the entire surface area. And the second one, remember the area, the surface area, you just take the area of just one face, and then you multiply that area with 6, because there are basically 6 squares. So there will be 6 squares in a cube. And then of course the last one there. I'm waiting for an answer. I want you to now start engaging. Let's look at the surface areas of these prisms before I can. All right, fine. Let's carry on now. I'm just gonna demonstrate to you that the first one here, you can see that in order to calculate the surface area of the cube, you will just need to calculate one area. By the way, the length is also the side. So in my case here, I've used the side, and I said that if you multiply the side by itself, you get the area of one of the faces of the particular prism, which in this case is a cube. And of course, you know that it is 8 millimeters. It is given as 8 millimeters, one of the sides. So all sides are equal 8 millimeters. So you multiply 8 by 8 to get 64. 8 times 8 is 64, and 64 multiplied by 6 gives you 384 square millimeters. So you can see this is how I've calculated the surface area of the cube. So basically that's how I've done it. And then the second one, you can see that we just multiplied the length by the height. So meaning that you've done the area of the 3 different rectangles which are formed in the rectangular prism, length times height plus length times breadth plus breadth multiplied by height. And then you simply multiply those by 2, because every face has got an opposite equal face. All right, corresponding face there. And then when you check our measurements, in this case, you had the length, which was 15 centimeters, and the breadth, which was 125 millimeters, and the height, which was given as the height there is 32 millimeters. So now that we have to, before you can work out anything, you must convert your centimeters to millimeters so that you can work with the same measurement or the same unit of measurement, rather. And of course, that is 15 centimeters, which now becomes 150 millimeters. Remember that if you convert from centimeters to millimeters, you multiply by 10. Why do you multiply by 10? That is for the simple reason 1 centimeter is equal to 10 millimeters. You can check that in your ruler there. 1 centimeter will be equal to 10 millimeters. So in order to convert anything centimeters to millimeters, you simply multiply by 10. 1 centimeter is equal to 10 millimeters. And of course, if you substitute correctly, then you should be able to find the correct answer there. Once again, the description is very clear. The rectangular prism is given with the different length, the breadth, and the height. And then of course, you should be able to see these faces that I'm talking about. When I say the three different faces of a rectangular prism, you've got the top one there. If you look at this prism, something called like a roof. If it's a house, then you've got the roof, that surface there. That's the first rectangle, and the front part of the house. That's another rectangle, and the side, the rectangle on the side, the right-hand side, that's another rectangle. So those three rectangles will be different. The area will be different because one, the top one, you multiply the length and the breadth, and then the side one or the right-hand one, you multiply the breadth and the height. All right. And of course, the front one as well, you multiply the length and the height. So basically, that is what you do. And behind, at the back there, there's also another rectangle which is equivalent to the front part. So the back rectangle is equal to the front rectangle. The top rectangle is equal to the bottom rectangle, and the side, the right-hand side rectangle will be equal to the left-hand side, or the rectangle on the left-hand side. So that is why you multiply by 2. Okay. And then the cube as well, you can tell that you just multiply the side by the side. Thereafter, you multiply by 6, and it should be able to give you the surface area. We have done many examples, and at this point, it should be very clear that a rectangular prism is just like your typical cardboard box, which consists of the face, the edge, and the vertex. The vertex is simply the corner, as I've said. A cube is therefore a rectangular prism with 6 identical squares. And of course, we have spoken about the surface area of a 3D object, and the next part will be the volume. I hope that tomorrow we will find time to thoroughly do justice to the topic of volume. And as a homework, I just want you to go and look at these 3 different prisms just to calculate the surface area. For now, you can leave the volume out since we are going to do the volume tomorrow. Just calculate the surface area in this case. Once again, this lesson, as always, is brought to you by the STEM Digital School in partnership with the Sasol Foundation. Until we meet again tomorrow, thank you very much indeed.